In mathematical induction and in mathematics, what do we say when we say statements? What are statements? So a sentence or a description which can be judged to be true or false, this is called a statement. For example, 2 divides 6. Is it a statement or not? 6 by 2, it gives you 3, so 2 completely divides 6. This is a statement and it is a true statement. Let me take another example. There are 5 days in a week. Is it a true statement or a false statement? If you see 5-day week, no, there are 7 days. So this is indeed a statement, but it is a false statement. So when we have talked about statements, let us see what are mathematical statements. So what are these mathematical statements? Statements involving mathematical relations, these are known as mathematical statements. For example, this 2 divides 6, it has some mathematics involved, so 6 divided by 2, so it is a mathematical statement. But if you take an example of 5 days in a week, is it a mathematical statement or is it not? 5 days week, this is not a mathematical statement because it does not involve mathematical relationship. Okay, so I'll give an example of how do we write this notation, and we'll take a few more statements and non-statements, specifically mathematical statements. For example, Pn, this is how we write. P1n you can write, P2n, and likewise. So this is the statement, or this is the notation of writing a mathematical statement. For example, we have Pn, let Pn be a statement. It is stating that 10n plus 3 is a prime. It's a prime. So what do we mean when we say P2? This means 10 into 2 plus 3. What is this? 23. It's a prime. But if you take P3, put 3 here. 10 into 3 plus 3, 33. It is not a prime. It is divisible by 3 as well as 11. Prime numbers are those which are only divisible by themselves or 1. Now let us take one more example before I can give you the Pn and Pn plus 1 stuff. If you want to write Pn and Pn plus 1. Now Pn is given by, say, 7 divides 2 to the power 3n minus 1. Now this is a statement. Now Pn plus 1 will be 7 divides 2 to the power 3. Here you put n plus 1. So 7 divides 2 to the power 3n plus 3 minus 1. So this is Pn plus 1. So we'll take an example of this Pn plus 1. Let Pn be the statement which says that 3 to the power n is greater than n. So we have to show that if this Pn is true, it is true for Pn plus 1 as well. How do we do this? So let us write this Pn plus 1 first. It would be 3 to the power n plus 1 greater than n plus 1. So this is simply 3 into 3 to the power n, or 3 to the power n plus 1 greater than n plus 1. How to get this? So now start with this one. 3 to the power n is greater than n. Now multiply both sides by 3. What do we get? 3 to the power 1 and 3 to the power n. So the power adds up. 3 to the power n plus 1 is greater than 3n. And this 3n can be written as 2n plus n. 2n plus n. But we know for every natural number, 2n will be greater than 1. You put 1. 2 is greater than 1. You put 2. 2 to the 4. 4 is greater than 1. So this will always be greater than 1. So why not to write 1 here? So when Pn is true, we say Pn plus 1 is also true from here. So this is how we prove it. So this is the discussion about the statements and mathematical statements. Mathematical induction, there are two words, mathematical, we know about this, we are studying mathematics, but what does this induction means? This induction comes from the physics. So induction means if say something is there and because of this some other thing happens, because of the action on this some other thing happens, we say that there is some induced effect or induced current, induced force like this. Same thing we are going to apply here, the principles of mathematical induction. First, we know that Pn is the referenced statement and we are talking about natural numbers only. So first condition is that P1 has to be true, that is whatever this expression is, if we put 1, that is if P1 is true, then for n equal to 1 it is true, then we assume that this Pn is true and we try to prove it for Pn plus 1. So if any n is there and we can prove it for n plus 1, we can always prove it for n plus 2, and this goes on and on. So this is an induction effect. So this is the mathematical induction. Now problems which are based upon the first principle and second principle of mathematical induction is that we need to solve it using certain criteria. And to describe this criteria, let us take one example. The example is like this, that we have to prove that this series 1 plus 4 plus 7 plus 3n minus 2, this is a series which is equal to half n 3n minus 1. So we have to prove by the principle of mathematical induction that for all which n, that is capital N, small n belongs to capital N, for all these n natural number, this holds, or we have to prove that whether this doesn't hold. So we'll start with the first step. The first step is simply, we know that this is Pn now. We'll check it for P1. So let us check it for P1. So now put here 1. For P1 this result will be 1. This is the left hand side. How about the right hand side? Let us put P1 also here. So half n is 1 and 3 into 1 minus 1. So do you get half? 3 minus 1 is 2. So you, 1. So you get 1 here and you get 1 here. That is P1 is true. So now we assume that this is true for this second step of mathematical induction is, we assume that this is true for any k or any m. This is true for any m, and when it is true for any m, we can just write like this. Same thing, 1 plus 4 plus 7. This is not true for any m. Now we need to prove it to be true for Pm plus 1. So let us write this in the form of Pm plus 1. 1 plus 4 plus 7. This is already there. Now we need to add one more term, which is m plus 1. So we are writing here m plus 1. Here also, let it be there. We'll prove it like this. Now from here to here, this is already, we have already said that this is true for Pm. So for this, we can write this one. For this left hand side, from here to here, we can write this right one. So we can write half m 3m minus 1 in this place. And what do we get from here? 3m plus 3 minus 2. So 3m plus 3 minus 2 is simply 3m plus 1. Okay, this is what you get, 3m plus 1. Now we have to prove this, that this is equal to half. For m plus 1, what this will be? M plus 1. For what this will be? 3 m plus 1 minus 1. This is what we have to prove from here. So now let us take this or multiply this. Take half common. M 3m minus 1 and 2 comes here, 3m plus 1. So half, you get 3m square minus m plus 6m plus 2. Now this is half 3m square, 6m minus m is 5m plus 2, and this is what? We can make factors of this. So I can write this as 3m square plus 3m plus 2m plus 2. So here you get 3m common, m plus 1 plus 1, 2m plus 2. So the factor will be 3m plus 1 and 2m plus 1. 3m plus 1 and 3m plus 1, 3m plus 1, and then we have this as m plus 1. This is m plus 1. So we have 3m plus 1 and m plus 1. Now this can be written as half m plus 1, and this one is, we can write it as 3m plus 1 minus 1, because 3m plus 3 minus 2. So 3m plus 3 minus 2, 3 minus 2 is 1 only. So this can be written as, this 3m plus 1 can be written like this. Now if you see this side, this one and this one is exactly similar. So by interpreting or by establishing that it is true for m, we established or proved that it is equal for, it holds for pm plus 1 also. So that is how we have proved by principle of mathematical induction the given result is true for all n belongs to capital N. So this is the principle of mathematical induction.